Hi, grade 11. So today we are looking at lesson 5.2, which is about special triangles. There's no handout for this one. It's another short lesson, so just take a few notes on a piece of paper and so that you can refer back to those later. And let's get started. So before we start talking about special triangles, we're just going to recall and note a few things. So just recall that you can only use SOHCAHTOA for right triangles. Write that down. Only for right triangles. So that also applies to what we're learning today, can only be applied to right triangles. And it's important to note that if a trig ratio is squared, you need to pay close attention to where the square is placed. So if I have sine squared 30, that means the whole thing is squared. So that would be sine 30 times sine 30. But if I have sine 30 squared, that means just the 30 is squared. So that would be sine 30 times 30. All right, so that's just important to know for your homework. Now, we have two triangles that we call the special triangles, and you are going to need to memorize these. The first one is the 45, 45, 90 triangle. So we have 45 degrees, and then 90. And then our side lengths are 1 and 1. And we can find the hypotenuse using that Pythagorean theorem, which is a squared plus b squared equals c squared. So that would leave me with 1 squared plus 1 squared equals c squared. 1 squared is 1 plus 1 is c squared. So 2 is c squared. Therefore, c is the square root of 2 because I take the square root of both sides. So that means the hypotenuse of this triangle is root 2. So now I can look at either 45-degree angle because they're the same. So I'm just going to pick one and I'm going to find the primary trig ratios of it. So sine 45, remember I'll just write SOHCAHTOA up here. Sine is opposite over hypotenuse. So say I'm looking at this one here, then the opposite side would be 1 over the hypotenuse, which is root 2. So sine 45 is 1 over root 2. Cos 45, cos is adjacent over hypotenuse, so the adjacent side is also 1, and the hypotenuse is also still root 2. So cos 45 is also 1 over root 2. Now tan 45, tan is opposite over adjacent, so opposite would be 1 over adjacent is 1, so that just equals 1. So using this triangle, which is one of our special triangles, we can find sine 45, cos 45, and tan 45, which are important measurements that come up over and over again throughout trigonometry. So if you memorize this triangle, which you need to, then you can quickly calculate those without having to type them into your calculator every time. All right, so that's the one special triangle. The other one is the 60-30. So we have our right angle, and then we have a 60-degree angle and a 30-degree angle. So this one will have 6 trig ratios, 3 for the 60-degree angle and 3 for the 30-degree angle. But first we'll calculate the side lengths. So this one is 1, the hypotenuse is 2, and then to calculate the third side length, we can use the Pythagorean theorem again. So a squared plus b squared equals c squared. This time we have a and c. So 1 squared plus b squared equals 2 squared. 1 plus b squared equals 4. B squared equals 4 minus 1. B squared equals 3. Take the square root of both sides. B equals root 3. So this side length here is root 3. So now, first we're going to look at the 60-degree angle, and we're going to do the 3 primary trig ratios for it. So if I have sine 60, that would be opposite over hypotenuse, so opposite would be root 3. Over the hypotenuse is 2. Then cos 60 is adjacent over hypotenuse, so that would be 1/2. And then tan 60 is opposite over adjacent, so root 3 over 1, which is really the same as root 3. All right, and then the ratios for the 30-degree angle. Sine 30 is opposite over hypotenuse, so the opposite of the 30-degree angle is 1 over the hypotenuse, which is 2. Cos 30 is adjacent over hypotenuse, so adjacent is root 3 over 2. And then tan 30 is opposite over adjacent, so that would be 1 over root 3. All right, so these are the two triangles you need to memorize. You need to memorize their angles and their side lengths. Once you know those, it'll make your homework a lot easier, and you'll be able to calculate exact values for different problems. So instead of just punching it into your calculator and getting a decimal, which you end up just rounding, which makes it an approximate answer, you'll be able to have exact answers with, say, root 2 or root 3 in the equation. All right, so some examples of how to use this. So example number 1. If I have sine 60 times cos 30 plus sine 45 times cos 45. And I say calculate an exact answer for this. So that means no rounding. So using your special triangles, which you can maybe just write on a sticky note for now and keep in front of you, and eventually you'll learn to memorize it. Sine 60, look back at that second one here, sine 60 equals root 3 over 2. So below we're just going to write equals root 3 over 2. Okay, now times cos 30. Cos 30 is also root 3 over 2. Plus sine 45, go back one more, sine 45 is 1 over root 2. And then cos 45 is also 1 over root 2. Okay, and now we can do this multiplication and addition and come up with a number. So first, root 3 times root 3 over 2 times 2. So remember, when you multiply fractions, you multiply the numerators and then you multiply the denominators. So root 3 times root 3 would be root 9. And then 2 times 2 is 4. Plus 1 times 1 is 1. And root 2 times root 2 is root 4. Now root 9 is the same as 3 over 4. Plus 1 over root 4 is the same as 2. Now in order to add fractions, I need a common denominator, which would be 4 in this case. So this one I would multiply by 2 over 2. So 3/4 plus 2/4 equals 5/4. So sine 60 times cos 30 plus sine 45 times cos 45 equals 5/4. So there will be situations in your homework or on a test or a quiz where I will say give an exact answer, and if you calculate this on your calculator, I would mark that wrong. Or I will say you may not use a calculator for this, and then you have to use the special triangles to calculate this. All right, number 2. Root 27 tan theta equals 3. So this symbol here, theta, is just another way of saying an angle measurement. So instead of saying calculate angle X, I'm saying calculate angle theta. All right. So the first thing I need to do is get tan theta by itself. So I need to get rid of that root 27. So I'm going to divide both sides by root 27. Now I'm left with tan theta equals 3 over root 27. Now how can I simplify this root 27? Remember when we just learned about radicals and we learned about breaking them up into perfect squares so that we could simplify them? That's what we're going to do here. So tan theta equals 3 over root 27 is the same as root 9 times root 3. So I can simplify that again. Root 9 is the same as 3. And now I can cancel out those 3's, and I'm left with 1 over root 3. So theta equals 1 over root 3. Now I'm going to go back to my special triangles and look at my calculations for tan. Which one equals 1 over root 3? 1 over root 3, 1 over root 3. Sorry, not this one here. That one's just root 3. So 1 over root 3 was tan 30. Therefore, theta equals 30 degrees. And I know that because this equaled 1 over root 3, and I was using tan. That's done using my special triangles. I didn't need a calculator for that. All right, and then this is a bigger problem. If I have this triangle here, this is angle beta S P Q R, and this side length here is 13, and this here is a right triangle, or sorry, a right angle, and this is 45 degrees. So that's what I know, and given that cos beta equals root 3 over 2, calculate the exact area of triangle PQS, so the big triangle. All right, so let's just first start by recalling the area of a triangle. So the area of a triangle equals base times height divided by 2. So base times height divided by 2. So my base is SQ times my height, which is PR, divided by 2. Now, SQ is actually 2 sections, which is SR plus RQ times PR divided by 2. So now I've just broken down my area. So now I know which components I need. So I need SR, RQ, and PR. Right? So I'm going to just work one at a time to try to calculate those. So I know they told me in the question here that cos beta equals root 3 over 2. So now I can calculate what beta equals. So if I go back to my special triangles, and I need to find cos something that equals root 3 over 2. So here I have cos 30 equals root 3 over 2. So then that tells me that angle beta equals 30 degrees. So beta equals 30 degrees. So I'm just going to write that here. All right, so I know that that's 30. Now, I'm going to start by finding PR. So that's this one here. So I know angle 30, and I know this hypotenuse is 13. So I need the adjacent, and I know the hypotenuse. Adjacent and hypotenuse. That leaves me with cos. So cos 30 equals adjacent, which is PR, over the hypotenuse, which is 13. So multiply both sides by 13. But I also know that cos 30 equals root 3 over 2, right? They just told me that over here. So now I have 13 times root 3 over 2 equals PR. So that's my calculation for PR. Now I'm going to find SR. I'm just going to write PR up here. Equals 13 root 3 over 2. I'm not going to simplify that any further because then I would have to round. So I'm going to leave it like that. Now, SR. So SR is, I'll do it in blue. SR is right here. I have angle beta, which is 30 degrees, and SR is opposite of it, and I have the hypotenuse. So I'm going to use opposite and hypotenuse, which is sine. So sine 30 equals opposite, which is SR, over the hypotenuse, which was 13. Now, looking at our special triangles again, what is sine 30 equal to? It's equal to 1/2. So that means 1/2 equals SR over 13. Multiply both sides by 13. Now I have 13 over 2 equals SR. Okay, so I'm going to write that up here. SR equals 13 over 2. Now I need to find RQ. And RQ, go back over here. Oops. I'm going to use, so this is what I need to find. I'm going to use this angle 45 here. And I know PR, because I calculated it here. So that would be opposite and adjacent. So I'm going to use tan for this one. So now I have tan 45 equals PR over RQ. I know that tan 45 from my special triangles is equal to 1, and PR, I already calculated, is 13 root 3 over 2, and then divide that all by RQ. Now multiply both sides by RQ to get it off the bottom. RQ times 1 is just RQ. These ones cancel out, so RQ equals 13 root 3 over 2. So now, using those three calculations, I can find the area. Now, area equals base times height over 2, which we calculated was SR plus RQ times PR, all divided by 2. So, SR plus RQ times PR divided by 2. SR we said was 13 over 2 plus RQ was 13 root 3 over 2. And then that's multiplied by PR, which is 13 root 3 over 2. And that's all divided by 2. So I'm just going to put, I'm going to add these two in the bracket here. And since they already have the same denominator, I can just add them together. 13 plus 13 root 3 divided by 2 times 13 root 3 over 2. And then divide by 2, I can multiply by the reciprocal. So the reciprocal of 2 is 1/2. So times 1/2 equals, so I'm going to multiply this by this, so expand in. Actually, first I'm going to put these two together. So 13 plus 13 root 3 divided by 2 times 13 root 3 over 4, because I'm multiplying the denominators together. Now I'm going to multiply numerators and multiply denominators. So 13 times 13 root 3 is 169 root 3. And then 13 root 3 times 13 root 3 is 169 root 9. And then the denominators are 2 times 4 is 8. All right, so I can simplify this root 9. So now I have 169 root 3 plus 169 times 3, all divided by 8, equals 169 root 3 plus 507 divided by 8. Now, if I divide 169 root 3 by 8, it's going to give me a decimal number, and 507 divided by 8 isn't a nice round number either. So I'm going to leave it like this, and that is my exact answer. So that's what we're talking about when we say give an exact answer. Keep those square root signs in there. Don't put a decimal number in and around, because then it's no longer exact. All right, so let me know if you have any questions and work on memorizing those special triangles. Have a good day.